we know like today चैट जीपीटी AI बहुत like explode हो रहा है. So लोग हर अपनी वेबसाइट पे अपने स्टार्टअप में चैट जीपीटी AI एवरीथिंग दे आर यूजिंग. सो लाइक और जो हमारा कंप्यूटर साइंस की जो स्ट्रीम है वो धीरे धीरे लाइक टेंड करती जा रही है AI की तरफ. और भी फील्ड्स हैं जो लाइक कंप्यूटर साइंस में हैं, लेकिन जो स्टैट्स दिख रहे हैं उस हिसाब से AI लाइक बहुत इम्प्रूव होता हुआ दिख रहा है. लाइक कुछ टाइम पहले तक टेक्स्ट टू वीडियो, टेक्स्ट टू इमेज बहुत लो क्वालिटी थे. अब आप देखेंगे लाइक इतने एडवांस हो गए कि आप डिफ्रेंशिएट नहीं कर सकते कि कौन सी चीज़ असली कौन सी चीज़ नकली. सो इन नाउ अब इन दिस टाइम में जो जॉब्स हैं, जो टेक है, जो न्यू स्टार्टअप्स हैं वो AI की तरफ टेंड कर रहे हैं. तो अब हमें पता होना चाहिए एक्चुअली AI है क्या. AI हमारे डेली लाइफ्स में एंटर कर रहा है. AI धीरे धीरे हर चीज़ में इंटीग्रेट हो रहा है. सो वी शुड नो हाउ AI वर्क्स, एंड एज अ डेवलपर यू ऑल शुड नो लाइक AI हाउ AI एक्चुअली वर्क्स इन लो लेवल, कि वो काम कैसे कैसे. सिर्फ API पता लगना, API कॉल करके यूज़ करना इज़ नॉट इनफ to build a career out of it. And not just career, to get to know more about of AI you should know at deep level how the AI works. So today we are going to learn the basics of neural networks and how actually AI works, and we are going to learn very basics about it. So it is not very advanced, but still you will know, you will get an idea how it works. So from here, from the first question we have like why deep learning and AI booming now. Actually the thing is, जब हम इसे देखेंगे कि लाइक आज से पहले कुछ साल पहले तक वी हैव अ लैक ऑफ कंटेंट. सो जो कंटेंट था हमारे पास वो कंटेंट की बहुत कमी थी. इंटरनेट पे जो डेटा अवेलेबल था वो डेटा हमारा बहुत कम था. क्यों? धीरे धीरे हमने देखा कि चीज़ें डिजिटलाइज होती गई. हर डॉक्यूमेंट लोग कंटेंट क्रिएटर बनते गए. उसकी वजह से डिजिटल डेटा और बढ़ता गया. लोगों के एक्सप्रेशंस, इमोशंस, एवरीथिंग स्टार्टेड गेटिंग ऑन digital platforms. So we started getting a very large amount of data from different sites, areas, and that's why we have lot of data to train our models on, and that's why they are getting more and more intelligent day by day. And what made the technology made all these possible is the GPUs. So if you see, Nvidia, the officially the biggest company of this world right now, it got recently. So Nvidia जो GPUs बनाती है वो कुछ टाइम पहले तक सिर्फ गेमिंग के लिए माने जाते हैं. लाइक कि GPUs हैं गेमिंग के लिए यूज़ होंगे, बट नाउ GPUs आर द बैकबोन फॉर द AI. एवरी कंपनी वांट्स टू हैव greater and best GPUs to train and run their AI models, and the technologies we are provided with are helping us to work on AI. So how the deep learning and neural networks actually helping us? So if you see, in a very basic example, the face recognition feature which is available on your like mobile app. So they detect your faces and show you like either you are authorized person or not. So how it actually works? So on very basic level, it detects your face, but for detecting your face it detects the basic features of face like eyes, nose, ears, and etc. All these. So it moves to a little lower level of features while it is detecting whether a frame contains set of two eyes or not, nose, lips, etc. Now to detect eyes, they again move to a little or more lower level. Like for this eye, whether this shade is there, for eyeball type thing is there. So all these things happen because of neural network. We are going to learn more about face recognition in CNN. Right now we are going to learn only basic neural network. So first thing, the first term we are going to introduce is forward propagation. This is the perceptron. The basic definition for the perceptron, you can say कि एक बहुत basic neural network like single layer input and single output. This is the basic neural network you can have, and this is called perceptron. Now how neural networks actually work? So let me give a very basic example. Let's say we have an input A, we have given it to a function A, and by this we got an output Y. Now this output y is our output of a neural network. We give input, we give it to a function gives an output. Now after that we will learn more what happens to the output, but for right now, for the forward propagation, this is what happens in our neural network. So first we have an input 1, input 2 and input 3. These are inputs. And what are these circles? So these circles are called neurons. What these neurons do? These neurons contains integer values. They hold some values, and their values get to a function operates on it and return another value to another neuron, and this is what happens in a neural network. A neuron contains a value, the value moves to another neuron by some addition, multiplication and any sort of functions you have to perform. Then it moves on and give you output like a function. So what happening is here, so we have three inputs right now, x1, x2 and xm. You are seeing w1, w2, wm. What are these? These are called weights. We have inputs and we have known as weights. Now what are weights? The basic definition you can learn about weights is एक इम्पॉर्टेंस इनपुट की फॉर द आउटपुट। एक इनपुट कितना इन्फ्लुएंस कर रहा है अपने आउटपुट को, उस चीज़ को अगर हम कोई क्वांटिटी से डिफाइन कर सकें उसे कहते हैं वेट। अगर लेट्स से आई विल गिव यू एग्जांपल, वी हैव 1x प्लस 4x प्लस 9x इक्वल्स टू लेट्स से a। अब अगर हम इसमें x की वैल्यू इनपुट करें, सबसे ज़्यादा अगर मैं x की वैल्यू लेट्स से 1, तो यहाँ पे आएगा 1, यहाँ पे आएगा 4 और यहाँ पे आएगा 9। वहीं पे x की वैल्यू अगर मैं 2 करूँ तो यहाँ पे आएगा 2, यहाँ पे आएगा 8 और यहाँ पे आएगा 18। सबसे ज़्यादा इन्फ्लुएंस कौन कर रहा है? ये वाला फैक्टर सबसे ज़्यादा इन्फ्लुएंस कर रहा है। वी विल से कि इस इनपुट के लिए जो वेट है ज़्यादा है, तो यानी इस टर्म का इन्फ्लुएंस इसके आंसर पे सबसे ज़्यादा है। क्यों? क्योंकि ये वाली चीज़ कम्प्लीटली हाफ ऑफ द आंसर इज़ इन्फ्लुएंसिंग। वेट कम्प्लीटली एक इन्फ्लुएंस होता है कि एक इनपुट का आउटपुट पे कितना इन्फ्लुएंस है। अब हम इसे कैलकुलेट कैसे करते हैं कि इनपुट है और उसे आउटपुट तक कैसे जाता है। वी हैव अ फंक्शन, let's say move to another slide which is better. Here you can see we have 3 inputs. For now ignore this one. We have this input and this input. We have to sum all the input by first doing the product with their weights. What we will do, x1 into their weight plus x2 plus their weight plus x3 into their weight. Now you have to calculate all of this. Then you have to add a bias. I will explain you what is bias, but after that you will have a z. This is a linear combination on your new inputs of the neural networks. Now afterward there is now there are few terms like bias and why we are doing this. We have to first do a linear combination of inputs by adding the product of the inputs with their weights, and then we have to add a bias. Now what is bias? Let's see what is bias. Let's say we have a graph, this. Now you must have seen data distribution for simple AI for models, like let's say these are the data points distribution for something, and these are data point distribution for something, and there goes a line which divides them from here, and you just calculate whether a random point lies here, then it must belongs to this category, or if a random point belongs to here, then this points belong to this category. Let's say this is red and this is orange. If our data point belongs to here, so it belongs to this and this side and this. But what happens our distribution is like this, where our data points are like this. Now you can't create a line like this. The more you do this, the model won't be a better. So the what bias help is, bias help us for setting a better suitable graph for our distribution. So instead of doing this, it takes our graph line and can move this to like this. So it can also help us in moving our this line to like on the y-axis as well. So it helps to graph to settle more in between the distribution, helping in more structured and more optimized model. So if for base level, bias sets a threshold for a like model that can manage to keep our model optimized. So now we have another process, like after we have calculated a linear combination of inputs with adding a simple bias. Now we have to do a non-linear activation. We have to use a non-linear activation function. Now what is the use of non-linear activation function? So the thing is, we have to use activation function to keep our inputs to keep our outputs from our inputs in a certain range, and for the required for our according to our requirements. For example, we are creating a model which needs to predict whether a photo is cat or a dog. So it is going to give a probability. So for such kind of models, we are going to use a sigmoid activation function. What sigmoid does is, on a number line, you are going to get output because you are doing a linear combination. So it can be very large or very small. So what you do is, you take your complete output and merge them to the range of 0 to 1. So now every output is going to be between 0 and 1, and you are going to get only 0. You are going to get the values between 0 and 1 as a probability. Activation function vary. So there are few popular activation functions, like we have a sigmoid, we have a ReLU, we have according to use cases. See, so we have a sigmoid activation function, and we have a rectified linear unit, which is ReLU. These are the most used, and this one is also used according to the requirements. So for the summarization, what happens, we have inputs, they get multiplied with respective weights, they get summed up, we add a bias to them. After applying bias, we apply an activation to set our output in a certain range according to our requirements, and to add a non-linearity. Now what is non-linearity? So let me just show you. Let's say we have a distribution for the graph like this. Now we can't draw a line like this for the distribution to keep apart our data. So we can't do this, we can't do this, we can't do all of these. Why? Because doing this will keep few data like this, few data like this in it, and it won't be better for our model. So to introduce non-linearity in our graph for model, what we do is, after non-linearity, our graph can adjust its line according to our distribution and set like this, so that the distribution of our model gets better. So whenever it is going to predict, it is going to predict according to graph. So as you can see, after that, we are, if we are going to do this, it is not going to like return better outputs for our model. So we have to perform our we have to keep our outputs in non-linear form, so that they can adjust, so the model can be adjusted according to the distribution of data points. Okay, so this is what the activation of function required for our neural network. So I hope you understand. So and one more important thing, it doesn't like this. So in the real neural network, it stays in thousands and millions. So we have to do matrix multiplication, and that's why the important thing came कि why tensor cores are used. Because AI ML में जो होता है कि जो टेंसर कोर्स होते हैं वो बहुत इंपॉर्टेंट होते हैं मैट्रिक्स मल्टीप्लिकेशन के लिए, एंड दैट्स वाई मैट्रिक्स मल्टीप्लिकेशन हेल्प करता है न्यूरल नेटवर्क में लाइक बहुत हैवी यूसेज के साथ, एंड दैट्स वाई यू शुड नो अ लॉट ऑफ कॉन्सेप्ट्स ऑफ मैट्रिक्स एंड डिटर्मिनेंट्स, and that's why GPUs are more suitable for AI because they have the tendency to like calculate matrix level calculation very fast on parallel level like this. So this is what I mean. You have a matrix 1 for the inputs, matrix 2 for the weights. You multiply and add them, then apply activation and bias, and then you have an output. This is the output of a neural network. See, you draw a line for non-linear function because this is a very simple neural network, so you don't need, because we have only two inputs, so you don't need a non-linear. That's why they just did this, and they were able to signify whether it belongs to this or this, something sort of things. But for building our actual neural network, we require non-linearity. So this is what simply we have already explained. You have to apply non-linearity, we have to sum, add bias. Now we have entered in multi-output perceptron, where you have same number of input as we had before, but the number of output is increased. Now why there is a need to have different multiple outputs? It's very simple answer. Just think of it. We are building a model where we are going to feed an image, and we are asking our model like, tell me whether it is a cat or dog. So what our model, we have asked for cat, so our model going to predict between 0 and 1. So if it is closer to 1 it is cat, and if it is closer to 0 it is dog. So what you have to do, you will have a neural network. It is going to calculate and predict a probability, and this probability, if this probability is near 1, then it is cat. If it is near 0, it is dog. So this is a single input. This probability can only predict the output of whether it is cat or dog. But what if we have a neural network which give us like, we are going to feed an image of a number. Let's say we write 7, and we have to feed this and ask what is this. So this is a handwritten 7, so our computer doesn't know what it is. So let's say we have trained a model and we are asking कि क्या है नंबर, ये कौन सा है, प्रिडिक्ट करो. सो टू प्रिडिक्ट वी हैव पॉसिबिलिटीज ऑफ 10 different numbers, like from 0 to 1 2 3 4 till 9. So and in that case we will be using multiple output, where you will be writing like 0 1 2 3 4 5 and this till 9, and this will be the proper probability for 0. Let's say we have written 7, so here the probability may be like 0.1. For 1 here will be probability like 0.1 or so 2 3 something. For probability of 0 for 7, so as it is the 7 only, so for the probability like maybe it can be 0.8 or 0.9 something. So all these probability will be less, and the probability for the 7, it will be higher. So this was how this was the reason why we use multiple outputs. Now let's see how the multiple outputs going to be done. So see, first we have a weight for z1, we have weight 2 for x2 for z2, and we have weight 3 for weight m for xm for z1. For with another color, we have x1 for weight 1, z1 for x2, this for x2 z2, and this for xm. So what it is going to happen for z1, it is going to calculate like the x1 dot w1 plus x2 dot w2 plus x3 dot w3 plus a bias for 2 for z2, it is going to give z2, and for above it is going to calculate x1 w1 plus x2 w2 plus x3 w3 plus a bias for 1 equals to z1. And this is how we have calculated our outputs for this. Now after that, the g function is going to apply the activation on both, and we are going to get the outputs. Now we are going to learn about like how and why weights are here and how they are going to affect and how we are what are their real use case in a neural network. So this is an example like how you can create your own very basic layers for neural network. One more concept, these all were neurons. If the set of neurons in a single line is called layers, so you have to know this is an input layer, this is an output layer, and in more complex, let's see this one, we are just seeing for the sake of thing. So for this is the set of input layer with the neurons, so we say this is an input layer, we are getting output here, and these set of neurons called output layer, and these which stays between the input and output, these can be multiple, these can be multiple like this, and the layers between input and output layers are called hidden layers. So just to name, I will explain. So here I hope the many of you who are watching this must be knowing Python at least on the basic level. So let's see how you can build this in a Python. So forget all like complex things, just you can see like we are initializing our weights. So initially weights are not fixed, so while training you have to initialize them with values. So you have initialized weights, you have also initialized the biases for each layers. Then as we know, we have to do matrix multiplication with our inputs and weights, and then again bias, again apply activation. So for rest of our lecture you have to remember what is the main thing in our, we have to matrix multiplication of what, input and weights, you apply bias, step 1 matrix multiplication, step 2 apply bias, step 3 apply activation, and this is how you have an output for another layer. These are the only these three things which are going to help us in the whole video. So remember these three steps. We have already learned this. So in this we have created single layer, you can create a dense layer, and what we call a dense layer when, as you know, we had only one input for the till the last slide, but now we have started getting the two in our outputs. So in more complex you will be getting thousands, maybe like more input layer. So for that you have to create more dense layers. So for this we have this one, it is, these are not output layers, remember, these are not output layers, output layers is going to come here, these are dense layer. And to initialize a neural network with two dense layer, you have to write a Python code like this with TensorFlow. You will understand, like it's not a big deal. This is the first and the very basic neural network with a hidden layer, output and inputs. This is very simple, just remember our concept. Inputs with respective multiplication, add a bias, we have Z1, add activation, you will get output. Inputs, add weights, add bias for Z2, activation, you get Z1. So for this you will get this one value, for this you get this, for another weights you get this, for another weights you get this. After getting this you again apply activation to get this, you apply activation to get this. So it's very basic level, just apply matrix multiplication, add bias, apply activation, and you have an output. Now why we all doing this, as I already explained this, you for particular Z2 we apply particular weights to our inputs, for this one these weights will be different. See, you can initialize the dense layer, they have initialized dense layer, you can initialize more dense layer as well according to it. These are all same.